So I am David Clark. My title here at MIT is Senior Research Scientist.
Dr. David Clark has been at CSAIL for a long time.
I started working here when I got my PhD in 1973. The joke I tell people is they forgot to tell me I could leave. The lab's changed its name twice since I've been here, but it's the same lab.
Computers were not originally designed to talk to each other. And back in the 70s, David was one of a small group of pioneers working together across academic organizations, industry, and the military to create a way for computers and computer networks to communicate. In other words, they were building the internet. As the Internet's chief protocol architect from 1981 to 1989, David had a big hand in how the Internet actually functions. But over the decades, he started to think less about the technical protocols that run the Internet and more about the economic and societal impacts of this thing he helped to build. And now that we've entered the AI age, David has a lot to say.
I initially thought, well, I'm just going to leave AI to the next generation. I'm this old internet guy, and boy, did that not work. I've been pulled into AI so hard.
From MIT CSAIL Alliances, this is Building 32. Join us once a month for a behind-the-scenes look, where we talk to the innovators, researchers, and scientists who shape one of the world's most influential research labs. I'm your host, Karen Given. All right, so I want to start with something I found when I was researching the early days of the internet. It's an email describing your participation at a TCP meeting bake-off in January of 1979. So let's start with the bake-offs. Describe what happened at these events and what that process tells us about how the internet was first developed.
So the proposal for the internet is a paper that was written by Bob Kahn and Vint Cerf. It was published in 74. I think they wrote it in 73. And it described roughly what TCP and IP were, those core protocols that facilitate the communication, but none of the details were there. So Vint convened a group of people to both refine the specification and also to implement it on different machines. And we would periodically get together to see if our implementations would interwork.
And in another document I found, it described the points that were awarded at these bake-offs for various things. And it was tasks like opening a connection, sending data, closing a connection, which seems to have been much harder than opening one. These tasks seem so simple today, but they weren't simple at all, right?
It's really important to understand how thoroughly we were in uncharted waters. It's not that they are hard. It's that we have to agree precisely on the set of steps that we would have to execute. So you can imagine explaining to people who have no idea how to meet each other, well, it's appropriate to shake hands, but you don't do that until this. And by the way, in the middle of a meeting, you don't stop and shake hands. And when you want to leave, it's appropriate to say certain things, which is socially understandable. And if you behave in ways that don't make sense, the relationship may break down. Well, that's with people, but with computers, you have to be very precise. And so just getting those steps right, specified carefully enough that everybody who went off and independently wrote code, all the programs would talk to each other. The hardest thing to get right was actually the checksum, which is the algorithm we run across all the bits in the message to make sure that it hasn't been corrupted. And the specification of the checksum algorithm, we went around and around and around. And I remember a bake-off in which on day one, we all agreed we would turn off the checksum code and get everything else working. And then on day two, we would turn the checksum code back on, and then we would get that working. It was an oscillation between refining the spec and refining the implementations. And the implementations were what proved the spec. And there were enough of them that if we really, when they interrupted, we were pretty sure we had a good spec.
So did these moments when everyone got together and worked down these problems feel like history was being made? Or did it just feel like a bunch of engineers working out a problem?
Sort of both. We would periodically sit back or go have a beer and try to understand what this was going to look like when it grew up. And we understood that we didn't understand. When you're sitting in the room there, you're just trying to solve the problem and you're trying to get this thing done. And we were very hands-on engineers. But, I like to remind people the internet is older than the personal computer, and computers are general purpose computers. You don't buy gamers today do buy gamer computers, but you can run Word or a browser or anything you want on your computer, right? So we wanted to build a network on which you could run anything because we were hooking general purpose computers together. So that meant we were building a network knowing that we had no idea what it was for, and that was a good thing, not a bad thing. And by the way, this totally freaked out the phone company because the phone company thought that in order to build a network, you had to know what it was for. The telephone network is for carrying telephone calls. And I like to remind people that when the modem was first invented, the reflexive reaction of the phone company was to ban them because that's not what it was for. But of course, computers are general purpose. We build them without knowing what they're for. So that's fine.
I've heard you say that in the beginning there were 12 of you and no one was really paying attention, so you could build whatever you wanted. That's not really true, is it?
Well, sort of. I mean, we had competitors in the network space. But yeah, in a larger sense, there were 12 of us in the room. And after it got real, it started to get real in the 1980s, of course, there were more people in the room. People say this insane thing that it's too bad the internet was designed by a bunch of academics that didn't care about security. And come on, we were funded by the Department of Defense. They absolutely wanted a secure net. Secure net was for the military. Our net was supposed to be insecure so that NSA could spy on it. That's not a surmise. They said it. And there was a guy from NSA who sat in our meetings. So as more people came in, yes, more people started watching. But that's not surprising. But in the 1970s, who cared?
In 1992, you gave a talk where you said, "We reject kings, presidents, and voting. We believe in rough consensus and running code." What did you mean by that?
You have to remember the context in which that talk was given, because the context is very important. During the 1980s, we started out with one working group. Computer scientists have a reflexive mechanism for dealing with things that get too big, which is we turn them into hierarchies. We created the Internet Engineering Task Force, which had working groups inside it. We decided that if we had a committee with a cool name, everybody wanted to join it. So we called it the Internet Configuration Control Board. And we assumed that title sounded so boring that nobody would want to join the group, which was true. It worked very well. But then we called it the Internet Activities Board. Now the A has been rebound. It's called the Internet Architecture Board. And the IAB thought it had some residual responsibility for where the internet was going. But one of our competitors in the late 80s and the 90s was the protocol suite that was being developed by the International Standards Organization, the ISO, and that was the Open Standards Interconnect thing, OSI. But we thought they were less competent, less likely to succeed, bureaucratically overloaded. But there was a lot of pressure on the internet community to migrate to the OSI standards. And one of the OSI standards was basically an equivalent to the internet protocol layer, the IP layer. So the IAB went off and they were at a meeting in Japan. It was in Kobe. I wasn't there, which was fortunate. And they decided that they were going to make a decision. And the decision was that the successor to the internet protocol was going to be the OSI layer, the IP layer. And they came back and told the IETF, as if they thought they had any authority to tell the IETF anything. And the IETF said, "You are the people we are no longer going to listen to. You're useless. You're irrelevant." They put their fingers in their ears and ran around screaming, "We don't hear you. We don't hear you." And it was a revolt from below. And the IAB realized they had no power. And Vint came to the IETF meeting after this happened. And there's a famous picture online where he actually sort of apologized. And if you know Vint, you know he always shows up in a three-piece suit. But he actually took his suit off and took off his shirt and showed he was wearing a T-shirt under which said IP on everything. And it was in that context that I was asked to give a talk. It was sort of a let's come together kind of talk. What are our common challenges? If you've looked at the slides of that talk, you'll realize we reject King. It's a throwaway in the slides. It's a throwaway. But it's the thing everybody picked up on. But when I said we reject kings, presidents, and voting, it's important to remember, in the context of that talk, it was not an unalloyed compliment because what we had just done was lynch our leaders, right? And so the question is, how do you make a decision? And one of the problems the IETF has always struggled with is how do you come to a conclusion? We don't get together in a meeting and vote. We make the code work. We debate. The consensus process was sometimes pretty rough. Okay. The debating style was sometimes very aggressive, but also the consensus process, no, 51%, no. It's a sense of the meeting thing. Are we there? And that's what I meant by rough consensus.
The way you described the early days of the internet, it sounds very much like anything could happen. You were up for just building this thing and seeing where it went. And it seems like while you were thinking about security, you assumed that people would do great things with the internet. Was there a moment when you started to wonder whether you had put too much faith in human nature?
Oh, yes, absolutely. The 1990s were definitely the transition decade toward commercialization, but the World Wide Web was benign. Anybody could run a server. That's still true. Anybody could build a browser. It's still true. They're hard to build, but you can grab one and modify it if you want. Of course, email was very decentralized. Nobody controlled email. And it wasn't until we began to see the emergence of the more centralized apps that we recognized that there was an issue we hadn't appreciated, which is the potential for manipulation by people with a lot of market power. If you go back to the 1970s, we knew people were breaking into computers and, we had pranks and we had serious stuff. Robert Morris's worm or virus, whatever you want to call it, which was the first major malicious thing that propagated across the internet. That's 1988, right? So we knew about that. And in fact, one of the things I predicted was the 1990s would be the decade of the cyber terrorist. I was off by 10 years. But, when Robert launched his worm, nobody could say they had not thought about the potential for malicious things to happen on the internet, and it happened at scale. So what I didn't understand, which came later, was the potential for malicious manipulation by corporate actors with market power. That was the realization that came later.
Well, tell me about that malicious manipulation. What did it look like?
Well, it emerges slowly because they have to learn how to do it. Facebook starts out as this funny little thing at Harvard, right? And look what it grows up into. Amazon starts out, trying to sell books, and look what it grows up into. It takes Amazon a while to realize, we can spy on what our third-party vendors are selling, and if it's popular enough, we'll have some made ourselves and undersell our third-party vendors, right? Because we can see what they're doing. It takes a while for Facebook to realize that they have to make money somehow and say, let's start selling ads. And then, but what kind of ad? We can see what they're doing so we can profile them. Yeah, it takes them a while to figure out how to be malicious. They are serving their own goals as opposed to the goals of their users.
Yeah.
And that's why we've always worshipped decentralized apps. But it's really hard to design successful decentralized apps. A centralized app is much easier to design. There's somebody in charge. If Facebook needs to pivot, somebody makes a decision and they pivot. In fact, there are very smart people out there who have looked at decentralized apps and said, in the real world, they can't succeed. So there was a small sort of negative epiphany in my life. I've told this story lots of times, but I'll tell it for you again. It was in 1995 when you're looking at checkpoints, and I was talking to an economist that knew all about the internet, and he said, David, you have to understand the internet is about routing money, and routing packets is a side effect, and you screwed up the money routing protocols. And I said, I didn't design any money routing protocols. And he said, that's what I said. And if you look at a centralized app like Facebook, the problem they solve is the money routing problem. We know exactly how the money flows. But if you look at a distributed social media site like Blue Sky, which is now trying to figure out how to raise money to stay alive, okay, they solved the packet routing problem first, and they're solving the money routing problem second. And he was right. If you want to solve a decentralized system, which might be more socially controllable, solve the money routing protocol, and the packets will come along.
So this brings us to like this thought where somewhere along the line, you began to think of the internet not as a technical problem, but as a societal problem, as a question of power. Tell me about that.
Well, that definitely starts to happen in the 2000s. It really comes into focus when you start to see abusive behavior emerge, in particular in the context of Facebook and Twitter and things like this, where you begin to see disinformation, various kinds of social manipulation. By the time you get to 2010, it's very clear that we ought to be thinking about this as a social phenomenon. We ought to be looking at social pathologies. And I would just say, looking at the present, I just wrapped up a 3-year project that involved collaboration with a behavioral psychologist, a woman named Sarah Wiedemann, trying to understand why people do the damn stupid things they do and how they're being manipulated online. And there's some very deep psychological needs, which the psychology literature clearly understands, but computer scientists don't read the psychology literature, which is why she and I were collaborating, that help you understand what I would say people like Facebook have figured out pragmatically, which is that the mechanisms for manipulating us derive from fundamental behavioral needs of people. So yes, that happened sometime in the 2000s, I think, what I used to call the uh-ohs.
That's before the world got more uh-oh-y.
That's the point. Yes, that's what I said, to quote my economist friend.
So I understand how to solve a technical problem. How do we solve for a question of power?
Well, the computer science response is to try to build decentralized systems, and it's an uphill battle. It's a fiercely difficult, contested uphill battle. Society's answer to this is antitrust. It's the Sherman Act. And the problem in the moment is that the US government is enthralled to big tech. But Europe is trying. They have the Digital Markets Act. They have the Digital Service Act. They have the AI Regulation Act. I can't remember what it's called. They have the Security Act called NIS2. And some people will say, oh, they didn't quite get it right. But they're working in there. They're trying. And you see how difficult the space is when, off the record, a company like Google will say that paying a $3 billion fine is just a cost of doing business. Right? So I didn't say that. But that's what you get when you get real market power. And I think had we recognized this earlier and come in and exercised some regulatory intervention earlier, it might have gotten better. But we were in a very laissez-faire time, and we're worshiping the god of competition, and we're hoping that if we deregulate, competition will come in and competition will discipline the market. And what we've learned is sometimes, but I mean, we have 3 cell phone providers now, which is, did you ever think 10 was realistic? No, 3 is better than 2 and 2 is better than 1. But there's a phenomenon that economists understand. It's called a network effect or tippy market. One of the reasons that we can have 3 cell phone systems is that they use common standards and they interoperate. So you and I do not have to be on Verizon for us to call each other. But Facebook built a walled garden. If I'm on Facebook and I want to talk to you, you have to be on Facebook. And so the market tips toward the one with the most users and the others die off. And what you really have to watch is environments that have network effect or tippy market. And we didn't understand the power of that soon enough. And then, of course, we allowed a few mergers. Facebook wants to buy Instagram. Well, sure, let them buy it. Why not? And I used to joke, the internet is sort of like an ecosystem. If you look at a natural ecosystem, if you look at the animals living in the African landscape, what's the primary interface that ties together the various animals in the ecosystem? And it's the eat, be eaten interface. And we said, well, at least our ecosystem is benign. There is no eat, be eaten interface. And it's called merger and acquisition. But It's done with the permission of the eaten because we pay them. The predators eat the losers, but they pay them so they can go away happy. Regulation is what's used to deal with this. But the regulatory space has become partisan polarized, which is very frustrating. And it's nutty, but that's where we are.
All right. So that brings us to where we are now, which is a lot of people have pointed out that the beginning of the AI age, it has a lot of parallels to the beginning of the internet age. Do you agree with that?
Yes, but
yeah,
the AI age has been trying to begin since about 1950. We've had cycles of AI hype and what's been called AI winter. And there are people today speculating that we're going to have another AI winter because of the vast overinvestment that's been made, unrecoverable investment that's been made in some of these big companies when they figure out they actually have to make money because they're losing money hand over fist. That some reckoning is going to occur, and we don't quite know what it's going to look like. But there's no doubt that from a social point of view, this cycle of AI innovation, large language models and generative models and things like that, has excited and empowered the public in a way that the previous cycles never did. And it's happened very fast. But I think part of the difference here is, you said we were 12 dudes in a room, right? The whole world is watching. And the speed with which people are piling into this space, again, more, I would say, the European Union or the European Commission than the United States, because we're, again, in thrall to big tech. But they're already passing AI regulation laws. So the gap from when this stuff hits the social space and people say, wow, I can ask ChatGPT something, and the time when the regulators wake up and said, we need regulation, it's not measured in decades here, which is what was happening with the internet. It's measured in a small number of years. So that's really the difference. And I think the speed of regulation here is informed by people's realization that the regulators came too late to the party with the internet and with not enough knowledge to know how to do it.
Well, the ethical concerns around the internet were big. The ethical concerns surrounding AI feel exponentially bigger. So it sounds like you're saying we have learned that we need to regulate earlier. Are there other things that we have learned from the internet that need to be applied here?
Well, one thing, there are some interesting parallels. The AI space does not feel as tippy as the internet space. It's not that everybody has to be on ChatGPT, or not everybody has to be on Claude. I can use Claude and you can use Gemini and somebody else can use ChatGPT. And in fact, when we have agents talking to each other, we have open standards. We have standards called agent to agent. It was generated by Google, but I think it's under the stewardship of the Linux Foundation now. So people have moved in this space to make the standards interoperable and open. So they're sending signals that they're not trying to build walled gardens. I think that the way you want to think about AI in this space is everybody's going to use it according to their inclinations and their needs and their abilities and their power. And what we learned on the internet is that there are a lot of people in that space who have very specific motivations, most of them not benign. Disinformation campaigns are put together by people who have a very specific agenda. They know what they're trying to do. They put the effort into executing the agenda. Most of us don't wake up every morning and say, well, the first thing I'm going to do today is defend myself from disinformation. We're much more passive in that space. And so I think what you have to see is AI is going to be used with people who have the motivation, the ability, the power. And that's why I think in the short run, AI is going to make it worse, because we're going to see agentic disinformation campaigns, campaigns that appear to be trying to influence the government with false messages from what appear to be constituents but aren't. There was this event that happened a few years ago where the FCC was asking a question that had some social significance. I can't remember what it was, but there's a process where you can submit a filing with the FCC. And they got 2 million filings, and they said, this is not realistic. And they looked at them, and they were identical. And it was clear these are all sock puppets. Somebody had just said, I'm going to try to create 2 million bots and send in these things. And the FCC just threw them in the trash. But if everyone had been custom written by an agent, it would have been much harder to tell which one was a real person and which one was a sock puppet, right? So, or a bot, as we call it. That's why I say AI is going to be used by people in ways that are manipulative, harmful, disruptive. And I think that realization came, again, in the AI space much sooner than it did when you look at the evolution of the application or the experience based on the internet.
Yeah. I mean, it's so interesting because it does feel like the sort of danger lights went off quicker, but so have this could change everything lights, right? Like it feels like the internet took a while. All you have to do is search YouTube and you can find these old clips of news anchors wondering what the internet is and why they'd even care about it.
Allison should know.
What is internet anyway?
Internet is that massive computer network, the one that's becoming really big now.
Just what is this main artery of the information superhighway?
Every business, no matter how large, no matter how small, will be on the internet in the year 2000.
Well, it's very hip to be on the internet right now.
I'm afraid that if I subscribed to something like internet,
You would really be hooked.
I would get hooked and I would never, spend time with my family.
And the reaction to AI seems really different. There's a lot more of course we want this. And yes, there might be some terrible side effects of AI, but why wouldn't I want something to do the boring work for me? And of course I want someone I can talk to, even if they're not real.
You're absolutely right. I will say, without apology, the benefit of the internet has outweighed the bad parts. And I think that's going to be true of AI, but we have to be much more sensitive to the magnitude of the bad parts. But yes, I think AI has, in some sense, slotted itself into the internet experience. And people have seen the internet experience evolving at a rapid rate. First, we had email, and then we had the web, and then there was internet radio, and there was beginning to stream audio. And I like to remind people, we were running something that looked like Zoom in the mid-1980s. We knew how to do that. What we did not have is megabit bandwidth to the home. We were just waiting for the bandwidth to show up. And I think people who've seen this space expanding, now we have streaming audio. Now we have streaming video. I think people are accustomed to the fact that the internet experience evolves rapidly. And so AI, I think, has just come in and say, that's it's the next thing that's happened on the internet. And we knew new things happen all the time. So this is not surprising. I think that's one of the reasons why AI is taken off, because it's seen as an experience.
So AI is here to stay, but when it comes to shaping it, the way that you help to shape the internet, what are the types of things we should be looking into?
There's a lot about the AI space that we can still shape. And there are a lot of tuning parameters in there that are still up for grabs. In the space of people, we've been struggling for quite a while with the question of how people are identified on the internet. We sort of have an email address, but it's not very well protected. I can pretend to be you and fool people and things like that. And there's a lot of work going into this question of how people should be identified. Well, it's become pretty obvious to people right now, we better figure out how AI agents are identified and what attributes they have. And that space is still up for grabs. There are people out there claiming, I am building the namespace for agents, but they haven't won yet. Okay. And in fact, I don't think anybody's going to win. I don't think it's a tipping market. I think we can have contested spaces. Very quickly, it became clear that we need to focus on what I'm going to call the AI experience. Do these things have identities? Do they have attributes? When you talk to them, what happens? Can they harm you? If they harm you, can you sue them? Are they autonomous AI things that have not any delegated authority from a person? Or is this an AI agent that belongs to a known corporation? It says, yes, this is my AI, this is my agentic interface to, my airline reservation system. You can talk to me agentically if you want. Everybody knows who that is. and they should know who that is reliably. It should not be some fake hacker in, Elbonia that is pretending to be American Airlines or Bank of America or whatever. And all the lessons we've learned about phishing and fraud and so forth, those lessons are front and center in the AI space, and there's still time to get in there. So that's why I jumped into the AI space. How can we avoid all of the abusive behavior that we see on the internet from being recast as agentic misbehavior?
You were optimistic when the internet was being made. Are you optimistic about the ability to do that now?
Well, I like to remind people we were techno-optimists. And what I did not understand until, as I say, sometime around the uh-ohs, is that it's okay to be a techno-optimist, but you can't be an overly socially optimistic person, okay? What you have to understand is that the problems we're dealing with here are not technical problems. They are problems of society. And so I'm still a techno-optimist, but I am much older and wiser with respect to understanding that systems are used by people according to their motivations, and not everybody has a benign motivation. That's clear. So yeah, I'm still an optimist, except about people.
Fair. Dr. David Clark, thanks so much for joining me.
It was fun. I'm always glad to have conversations like this. And thank you very much for having me.
David Clark is a senior research scientist at MIT CSAIL. That's the Computer Science and Artificial Intelligence Laboratory. To keep up with all things Building 32, check out our website, csail.mit.edu/podcast. Please be sure to follow us on your podcast app. And if you've enjoyed this conversation, please consider leaving us a 5-star rating or review. This show is produced by Tina Mack with help from Andrew Zukowski and Mary Kat Boyette. I'm Karen Gibbon. Thanks for listening. We'll be back with another episode on August 10th.